Today's lesson is going to be on isotopes. So what is an isotope? An isotope is an atom that has the same number of protons and electrons, but it has a different number of neutrons. So if neutrons are found in the nucleus, and the nucleus of the atom is what makes up the mass number, then isotopes would also have a different mass number. And this brings us into our periodic table. And if we look at our periodic table, we notice that these elements all have a decimal. So where does that decimal come from? And the answer is isotopes. This mass is the average mass of all the different isotopes found in nature. So when we are going to calculate that, now we're going to be on our average atomic mass worksheet, and we're going to be doing problem number 1. Find chlorine's average atomic mass. If approximately 80% of the chlorine is chlorine 35 and 20% is chlorine 37. So what do we notice here? We notice the word chlorine, and then there's a dash with the 35 and a dash with the 37. So this is one way in which we are able to write the symbol for an isotope. And that 35 is going to be the mass number of the isotope, and that 37 is the mass number of the second isotope. Another way that we can write a symbol is we can actually put the Cl, which is the symbol from the periodic table. Now, chlorine has an atomic number of 17, so we would put that down at the bottom, and we put the mass number up at the top. So if we wanted to write chlorine 37, we would do the same thing, the mass number 37 at the top and the 17 down at the bottom. Now, this is important here, 2 different ways to write the symbol for an isotope. When we write it as chlorine 35, it's understood here that the atomic number is 17 because chlorine always has an atomic number of 17. That's the number of protons, and that's the determining factor for that particular element. The protons determine the element. So let's calculate number 1, the average atomic mass. Now this is going to be a weighted average, the same way that I would figure out your grade in this class. It's a weighted average. So I'm going to take the mass number of chlorine, which is 35, and I'm going to multiply it by its relative abundance, which is 80%. And when I multiply by 80%, I'm going to move my decimal place to the left twice. Then I'm going to add the mass number from the second isotope, which is 37, and I'm going to multiply this 37 by the weighted average, which is 20%. Again, when I multiply by a percentage, I'm going to move my decimal place to the left 2 times. So when I plug this into my calculator, I end up with a value of 35.4. And that's an atomic mass unit. 35.4. So what do I see on my periodic table? 35.45. So this value is slightly different because the more precision there is with the percentages, the more precise our values are on the periodic table. So let's do another example here in a second. But we noticed in this, our calculation of chlorine was very, very close to what the periodic table did. So let's do the second example. We're going to calculate the average atomic mass of oxygen, where its abundance in nature is 99.76% for oxygen 16, 0.04% for oxygen 17, and 0.2% for oxygen 18. So what are we going to do? We're going to take the mass of our first oxygen, which is oxygen 16, and multiply it by its percent abundance, which is 0.9976. And then we are going to add oxygen 17, which is at 0.04%. So that's going to be 0.0004. And then we're going to add oxygen 18, which is 0.2%. So that would be 0.002. And then we're going to simply plug that into our calculator. So 16 times 0.9976 plus 17 times 0.0004. And then that's going to add 18 times 0.002. And we end up with a value, according to our calculator, of 16.0044. Now, when we write our mass numbers, we're going to go out 2 decimal places. So the best way to write oxygen would be 16.00. And if we look at oxygen on our periodic table, we see that it does in fact have a mass of 16. So what does this tell us? This tells us, if we look at our different masses, we have 16, 17, and 18. The overwhelming majority of oxygen has a mass of 16. Coming back up here to chlorine, the overwhelming majority of chlorine has a mass of 35. We've been rounding our decimal places to the nearest whole number. So 35.4 rounds to 35, and 16.0 rounds to 16. So what does that tell us? When we round to the nearest whole number, that also gives us the isotope that is going to appear in nature in the most abundant amount. So the most common isotope. So let's look at our periodic table. Aluminum. The most common isotope of aluminum would be aluminum 27. This 26.9 rounds to 27. The most common isotope of zinc would be zinc 65, because 65.39 rounds to 65. So when we round to the nearest whole number on the periodic table, again, that gives us the isotope, which we call the most common isotope, meaning it is the most abundant in nature.